Okay, let's dive into this. Welcome to this explainer. As researchers, entrepreneurs, and executives, we essentially spend our entire careers trying to see around corners. But today, we're unpacking a profound cognitive science discovery that honestly completely shifted how I think about intelligence. We aren't looking at markets today. We are looking at the hidden mechanics of visual judgment itself.
So, here's our roadmap for today. We're going to peel back the onion on how humans and machines actually process the world. We'll start with inventing the straight line, then move into hidden judgment and sketches, the AI stroke budget, the chart reading illusion, and finally, pattern matching versus understanding.
All right, let's kick things off with Section 1, Inventing the Straight Line, and how we make the raw world legible.
We have to start with a weird, simple fact that most of us literally never stop to notice. Nature never gave us a straight line. Seriously, think about it. Look at a tree, a mountain range, a river. You won't find any perfect grids or right angles out there. And this one simple observation is actually the foundation of everything we're discussing today.
The natural environment, forests, river deltas, the raw, tangled world, is wildly chaotic. It's just too complex to reason about directly. So, what did we do? We had to invent tools to handle it. Number lines, grids, basic geometry. We didn't discover these things lying around in the woods. We invented them specifically to make a messy, tangled world legible enough for our brains to process.
And this habit of ours, marking up our environment, it's ancient. We're talking 80,000 years ago, with cave paintings starting the grand project of turning the invisible into something workable. Fast forward to the 17th century, and you've got Descartes inventing the coordinate system, which suddenly solves the centuries-old problem of how to double a cube's volume. Then, by the 20th century, we get Feynman diagrams visualizing subatomic particles that no human eye will ever actually see. These aren't just pictures. They are highly durable, load-bearing, cognitive tools that literally still run every math curriculum on Earth today.
Which brings us to Section 2, Hidden Judgment in Sketches, or the cognitive science of drawing.
Now, what's really interesting about this history is that it reveals exactly what AI is missing. Researchers recently had people play a simple drawing game. And notice this, the sketchers didn't just mechanically reproduce what was in front of them like a human photocopier. Instead, they made constant unconscious judgment calls. If an object had close competitors, like say, a specific type of bird among other birds, they added way more detail. But if it stood alone without any chance of confusion, they simplified it. Humans intuitively track exactly what their audience needs in order to understand. Nobody teaches us this. It's just a built-in cognitive instinct. For example, when participants were asked to draw a machine, they produced two wildly different types of drawings, depending entirely on the goal they were given. Explanatory drawings really highlighted the moving, causal parts. They were completely optimized for teaching someone how to actually operate the thing. But depictive drawings, those emphasized the overall appearance and the background, optimized purely so someone could recognize which machine it was. You literally cannot optimize a single drawing for both. Communication always involves a trade-off, and we humans instinctively navigate that, adjusting our visual tools on the fly to fit the exact goal.
Okay, move into Section 3, the AI stroke budget and testing resource constraints.
So what happens when we bring AI into the mix? Well, the good news for those of us deploying these models is that AI vision models trained on ordinary photographs actually generalize surprisingly well to simple, sparse sketches. Recognizing something by resemblance isn't some magical human-only trait, it's a mechanism neural networks replicate with real accuracy. But there is a catch. When researchers compared confidence levels between humans and AI on the exact same images and questions, humans were far more reliable and consistent. AI does a great job, for sure, but a massive reliability gap remains.
To really test this, researchers use what they called a stroke budget, which is a perfect proxy for a resource constraint. Imagine you only have a few pen strokes allowed. At high resource levels, where you can use many lines, both humans and AI produce highly recognizable sketches, no problem. But when resources get scarce, humans simplify by preserving the essential communicative meaning of the object. AI, on the other hand, diverges sharply. It simplifies in fundamentally alien ways. So they aren't just using different math under the hood, they are solving the underlying problem in a completely different way.
Let's look at how this applies to our daily work in Section 4, the chart reading illusion, deconstructing graph literacy.
As executives, we look at data graphs constantly, right? And we tend to assume reading a chart is just a single automatic reflex, kind of like recognizing a face. It absolutely is not.
It's actually a fragile chain of 4 distinct cognitive steps. First, perceiving the visual elements. Second, knowing exactly where to direct your attention. Third, mapping what you see onto the specific question you're asking. And fourth, translating that mapping into a concrete answer. Because it's a chain, a break at any single link causes a failure. 2 people can arrive at the exact same wrong answer for entirely different cognitive reasons.
And this brilliantly illustrates a massive trap we can fall into. The danger of relying on surface-level metrics is immense. Leading multimodal models, like GPT-4v, can approach human-level accuracy scores on benchmark graph reading tasks, but if you look closely, the actual pattern of AI mistakes looks absolutely nothing like how humans get things wrong. Matching a benchmark score is definitely not the same as matching the underlying reasoning process. If we are going to hand more high-stakes decisions over to these systems, we absolutely have to understand this distinction.
See, humans are incredibly deliberate chart readers. We don't just blindly grab a bar chart out of habit. Our choices track very closely to the specific question we are trying to answer. Interestingly, when researchers reviewed decades of standard textbook categories for testing graph literacy, stuff like find the maximum or identify a cluster, they found these categories poorly explained why humans actually make errors. It turns out a newer, simpler 4-factor model explains our error patterns far better than the traditional taxonomy educators have relied on for years.
Which brings us to our final part, Section 5, pattern matching versus understanding and the macro implications.
We need to get our definitions crystal clear here. Pattern matching is mechanical. It's the ability of an AI to recognize visual resemblance based on vast oceans of training data. Understanding, however, is a completely different ballgame. Understanding is a stack of interlocking human judgment calls, honed over tens of thousands of years, about what actually matters and what can be safely ignored. AI is closing the gap on the mechanics incredibly fast, but it is nowhere close on the judgment.
So, the crucial point is captured perfectly in this takeaway from the research. The gap between recognizing a pattern and understanding it is exactly the gap between a tool and a mind. If your organization is operating on the assumption that an AI model hitting a benchmark means it matches human reasoning, you are taking on massive unquantified risk.
Look, this research is not just some academic curiosity. It is a direct mandate for capital allocators, founders, and policymakers. Historically, every single generation sees further by standing on the visual tools built by the previous one. We cannot afford to just blindly trust benchmark scores. We have to actively foster true visual and AI literacy inside our organizations if we want to thrive.
Which leaves us with this final, really provocative question to think about. Does AI become the next rung on our cognitive ladder, helping us see further? Or does it quietly replace the climbing altogether? Thank you for joining me for this explainer. I hope you challenge your assumptions and use these insights to build the future with clarity.